It's a great day, everyone. Our concentration is on the geometric sequence, particularly the nth term. Let us remember the rule. If the first term of a geometric sequence is a sub 1, the nth term is a sub n, and the common ratio is r, then we have a sub n is equal to a sub 1 multiplied by r raised to the difference of n and 1. Let us take note again. The n here as a subscript. We also have the n there as the superscript. Then we have here a subscript 1, and we have a minus 1 there as a superscript. Let's see. Example number 1. The first term of a geometric sequence is 8 tenths, and the common ratio is 5. What is the seventh term of the sequence? What is the very first that we're going to do? We always have to write the formula, which is a sub n is equal to a sub 1 times the r, which is raised to the difference of n and 1. That is the formula. Next, we have to substitute whatever is given to that formula. We have, from the question, what is the seventh term? So we have a sub 7 is what we're looking for. And we have the first term, which is 8 tenths. That's the first term. Then we have the common ratio, which is 5. And of course, since we are looking for the seventh term, you will see here again, there, 7 for the subscript, 7 for the superscript. And then we have here purely computation. What will be the very first operation that you are going to do? That would be simplifying the exponent because that is a group. We have a sub 7 is equal to 8 tenths multiplied by 5, which is the common ratio. Then you have your 7 minus 1 is 6. We have simplified the exponent. Then what's the next operation? We have to do first your 5 times 6 before we are going to 5 raised to 6 before we are going to multiply by 8 tenths. You can do the calculator or you can do it the long way, and you will be arriving at the answer of a sub 7 equivalent to 12,500. We can now answer the question, what is the seventh term of the sequence? The seventh term of the sequence is 12,500. Second example. The first term of a geometric sequence is negative 12, and the common ratio is 1/2. What is the sixth term of the sequence? Again, so that you will get used to it, write the formula. And from the formula, you check now the information given in the problem and substitute it in the formula. Since we are looking for the sixth term, then we write here a sub 6. And what is our first term? The first term is negative 12. What is the common ratio? That is 1/2. We have written it there. Then, of course, we have the exponent 6 minus 1. So we are done with the substitution. And again, what is the first to simplify? Simplify the exponent, which is 6 minus 1. And what is 6 minus 1? You have there 5. Then, after simplifying the exponent, you now simplify the exponential expression 1/2 raised to 5. And 1/2 raised to 5, you can use your calculator for that, before you're going to multiply that with negative 12. And when you do that, you will be arriving at the answer, which is a sub 6 is equal to negative 375 thousandths. That is making use of the calculator. What if I would not like to use the calculator? So that we now have here negative 12. I will now have to apply the definition of exponential. 1/2 raised to 5 means I will be having 1/2 as a factor 5 times, so that I will write 1/2 5 times. Okay? Then again, I can rewrite 12. I may not write 12. I may rewrite it as 2 times 3. That is the same as 12. So I can say 2 divided by 2 is 1. 2 divided by 2 is 1. Thus, I am left in the numerator with a negative 3. Negative 3 times 1 is negative 3. 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 So we now have a negative 3. Then in the denominator, I will now, I am now left with 2 times 2 times 2, which will give me an 8. Thus, we can also have our answer as the sixth term is a negative 3 eighths, which is equivalent to the decimal counterpart of negative 375 thousandths. So, answering the question, we now have the sixth term of the sequence is negative 3 eighths or negative 375 thousandths. Example number 3. What is the ninth term of the geometric sequence 2, negative 6, 18, negative 54? We are given a list. So how are we going to do that? Again, there is no common ratio given, thus you have to establish the common ratio. How do we solve for the common ratio again? Recalling, from the current, from the right going to the left, you're going to divide the terms. So we have negative 54 divided by 8, 18, you have a negative 3. 18 divided by a negative 6, you have a negative 3. And negative 6 divided by negative 6 divided by a 2, you will have a negative 3. Thus, we can clearly say that the common ratio is equivalent to a negative 3. Thus, we can use that now in the formula. We are given, substitute now, 2 for a sub 1. This is our first term. That is our a sub 1. And we now have here 9 for n, because that's what we are being asked for the ninth term. Then, of course, we have negative 3 for the common ratio. Again, what's the first to simplify? The group in the exponent 9 minus 1. So 9 minus 1 is 8. Then we continue the operation. We now have to raise negative 3 to 8. And remember that when you raise a negative to an even exponent, you will come up with positive. So, negative 3, you raise that to 8. Then you multiply that by 2. You will now arrive at the answer, which is equivalent to 13,122. Again, we have been applying the same thing for the three examples. We use the formula a sub n is equal to a sub 1 times r raised to the difference of n and 1. Then we substitute the given information, a sub 1, the common ratio, and the value of n. We perform the operation applying the GEMDAS rule. Grouping first, which in this case is the group of the exponent, and then your exponential expression before we are going to multiply. Remember that. But what if the first term, what if the first term is not given? If instead of a sub 1, we are given two non-consecutive terms, say we have an a sub x and an a sub n, and a sub x could be your a sub 3, and your a sub n could be the a sub 10, or your a sub x could be a sub 7, and a sub n could be a sub 15. We use a derived formula. Again, the derivation is not discussed in this video because what we're doing here are examples. So we make use of the derived formula. A sub n is equal to a sub x multiplied by the common ratio, which is raised to the difference of n and x. Again, take note, n here as a subscript, n here as a superscript, x here as a subscript, x here as a superscript. Let us apply this formula in exercises. Example number 4. The third term of a geometric progression is 12, and the eighth term is 384. What is the first term? Can we immediately identify the first term? Remember the formula, we always need the common ratio. So how do we solve for the common ratio? In the previous video, you were introduced to again another derivation of how we can solve for the common ratio if we don't have consecutive terms and if we are not given the first term. So that we have here the common ratio is equivalent to the n minus x root of the quotient of a sub n and a sub x. So let's do that. Knowing that we have here, let's rewrite third term, so that would mean to say a sub 3, we have here 12. And eighth term, we mean to say a sub 8 is equal to 384. And you're being asked, of course, the first term. But before we can do that, we have to have the common ratio. And applying the formula, we then have a sub 8 divided by a sub 3. So our subscripts are 8 and 3. So that's what we are going to write here as the index, 8 minus 3. So performing, 8 minus 3 is 5. So we're looking for a fifth root. What is a sub 8? We have 384. And what is a sub 3? We have a 12. And if we're going to simplify that, 384 divided by 12, we will be arriving at the fifth root of 32. Your 384 divided by 12 is 32. Then, you get the fifth root of 32, or we can now say, we rewrite 32. 32 is actually a power of 2. That is equivalent to 2 raised to 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, and times 2 is 32. Thus, we can now say 2 raised to 5 divided by the 5. The index is 5. The r is equivalent to 2. We now have a common ratio is 2. Then it is your choice if you're going to make use of formula, the derived formula, or you're going to go from the third term, go left to the second term, go left to the first term. Let's use the derived formula. And the derived formula is a sub n is equal to a sub x times r raised to the difference of n and x. So what we can use again here, either a sub 3 or a sub 8. It's your decision. But since I am the one doing this, I would like to deal with smaller numbers. So I would say a sub 3, I will use a sub 3. And a sub x, this is actually a sub 1 because we are given the first term, or we are looking for the first term. Then we now have the r, which is equivalent to what we have solved for, r. Sorry for that. The eraser is not working. It's not working. So may I just cross this out and then I will rewrite it here. A sub 3 is equivalent to a sub 1 multiplied by the r, which is raised to 3 minus 1. So that we can now say a sub 3, which is given to be 12, and a sub 1 is what we're looking for. And then we have the common ratio, which we have solved to be 2. And then simplifying 3 minus 1 in the exponent, that is 2. And we have 12 is equal to, of course, what's 2 squared? That would be 4. And dividing both sides by 4, we will be arriving at a sub 1, which is equivalent to 3. A sub 1 is equivalent to 3. All right? Now, I may not want to do that. As I said, I may just simply start with the third term. So the third term is 12. This is your a sub 3, which would mean to say I would go left and I have a sub 2. And what will I do in order to get an a sub 2? I am going to divide 12 by the common ratio, which is equivalent to 2. And 12 divided by 2, I will get a 6. And I know that if I go left, I will be arriving at a sub 1. So I can simply say 6 divided by the common ratio, which is 2, and I will be arriving at 3. Thus, I can still say that a sub 1 is equal to 3. So there are many ways by which we can come up with the correct answer here. So have we answered the question? What is the first term? Yes. The first term is equal to 3. Okay. Let us have the last example. Find the second term of a geometric sequence when a sub 3 is equal to 81 and a sub 7 is equal to 16. So again, what are we given? We are given the second term to be, oh, that's what we're looking for. We're not given. We're looking for a sub 2. When we are given your a sub 3, which is equal to 81, and you have your a sub 7 is equal to 16. So by the given alone, you know that your r is a fraction, considering that you have an a sub 3 which is greater than a sub 7, which is 16. Again, what's the very first that you are to establish? The common ratio. So what again is the common ratio that we're going to use? Okay, you have the formula. So let's see. R will now be equivalent to, again, what are we given? A sub 7 and a sub 3. So our index would be 7 minus 3. So that R is equivalent to, what is a sub 7? A sub 7 is 81. A sub 7 is rather 16. Since the eraser is not working, may I just rewrite it here. The R would be equivalent to a sub 7 is 16 divided by the a sub 3, which is 81, and you have there 7 minus 3 is equal to 4. Thus, we will be arriving at, okay, we have there, we can rewrite. What is 16? 16 is rewritten as 2 raised to 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. How do we rewrite 81? 81 is also 3 raised to 4. Thus, by the law of exponent, we can say we're getting the fourth root now of 2/3 raised to 4, giving us what value of the common ratio? The common ratio would now be equivalent to 2/3. That is the common ratio because you're getting the fourth root of a power of 4. So you will just be arriving at the base. Now that you have the 2/3 as the common ratio, you can now solve for the second term. How are you going to solve for the second term? Do you need to use the formula for the a sub n is equal to a sub 1 multiplied by the r raised to the n minus 1? Or you simply go from a sub 3 going left to a sub 2? Again, it is your decision. Use whatever is easier for you. But inasmuch as I am given here an a sub 3, then I have an a sub 7 which is given. A sub 2 is directly to the left of a sub 3. So what I am going to do, I will simply divide a sub 2 by the common ratio. Then I will be arriving at a sub 2. Thus, I will use a sub 2 is equivalent to a sub 3 divided by the r. So what is a sub 2? A sub 2 is equivalent to a sub 3, which is 81, divided by the common ratio, which I have gotten to be 2/3. Again, take note, that is the longer bar. So how do we solve for a sub 2? Again, dividing fractions, easy as a pie. Flip the second and multiply. So I have flipped here, or have gotten the reciprocal of 2/3 to be 3/2. And can I divide 81 by 2? Obviously not. But I can multiply 81 multiplied by 3. So 81 multiplied by 3, that would be 1 times 3 is equivalent to 3. And then 3 times 8, that's equivalent to 24. So 243 halves. That would be the value of a sub 2. Were we able to get the answer? Yes. 243 divided by 2 is a sub 2. Or, how else can you rewrite that? You can rewrite it as a decimal, you can rewrite it as a mixed number, or simply, in order that you might be committing again added error, leave it as that. We can accept that the second term will be 243 halves. So that's it. Simple exercises for determining the nth term, any term at that. It could be the first term, it could be the seventh term, it could be the second term, and so on. So this ends my discussion today as a review for determining the nth term of a geometric sequence. Thank you again for watching. See you in the next video.